All right, everybody. So we're going to do questions for the seasons, part ones, questions for the year 23-24. And so it says, based your answer to the following questions on the diagram below and on your knowledge of Earth science. The diagram represents Earth in its orbit. Letters A through D represents locations on the first day of each of the four seasons. Zoom in a little bit. So it says identify the latitude where the sun is directly overhead. Keyword, the sun is directly overhead when Earth is at position B. Include units and compass directions in your answer. So when we want to find out the latitude where the sun is directly overhead at location B, I first got to find out what season is this? What season is this in? So one thing you look in particular to find out what season it's going to be is you have to look at the North Pole. So when you see the North Pole, I see that the North Pole is tilting towards the sun. If the North Pole is tilting towards the sun, this lets me know that B is occurring during the summer solstice. All right, it's when the North Pole is tilting towards the sun. If we take a look very quickly, even on our notes, it says right here, the summer solstice is when the North Pole axis tilts points towards the sun. It's just another example, the North Pole tilting towards the sun. So what latitude is the sun directly overhead, right? Giving an image like this. Well, it says right here, the sun forms a 90-degree angle at noon at 23.5 degrees north. So that lets me know that the sun is at a 90-degree angle at noon at 23.5 degrees north. So therefore, my answer is going to be 23.5 degrees north. That's your answer. All right, so number two. Number two says the following. It says, based your answer to the following questions on the diagram in your answer booklet and on the knowledge of Earth science. It says the diagram represents the sun's daily apparent path for the first day of the three seasons at 43 degrees north latitude. The solid lines represents daytime paths as seen by an observer at this latitude. The dashed lines represent the nighttime paths that cannot be seen by the observer. All right, and so all three of these positions represents the sun at solar noon. So it says, list the three dates shown on the diagram from the least number of nighttime hours to the greatest number of nighttime hours. So one thing we do have to just keep in mind, if you want the greatest number of nighttime hours, right, that means you need the least amount of daytime hours. All right. Least number to the daytime. So that means whatever is going to give me the greatest number of nighttime is going to be giving me the least amount of daytime. Whatever's going to give me the least amount of nighttime is going to be the greatest amount at daytime. All right. It's something to keep in mind. And the greatest amount of nighttime hours will be the least amount of daytime. Okay. So the rule is, I change the color. The rule is that the higher the sun's path is, right? The higher the sun's path is, the more daytime hours we're going to get. Okay. So which one is going to give me the smallest amount of nighttime hours is going to be the one that gives me the greatest amount of daytime hours. So June 21st has the highest path, which means that it's going to give me the greatest daytime. So if I have the greatest daytime hours, that means I have the least number of nighttime hours. So therefore, my first answer is going to be June 21st. It's going to give me the least amount of nighttime. Then which one is the second highest? March 21st. And then which one is the lowest? The sun path that's the lowest is going to give me the greatest amount of nighttime hours, which is going to be December 21st. And that is your answer. So keep in mind, they're asking for the number of nighttime hours. That's why we got to make sure to read. So the one that has the greatest number of nighttime hours has to be the one that has the lowest sun's path. Okay, the one that has the highest sun path gives you the least amount of nighttime hours. All right, so number 3 says, base your answer to the following questions on the graph below and on your knowledge of earth science. The graph shows the altitude of the sun for a 24-hour period of a certain day of the year for 4 different latitudes. And so it says, identify the latitude that has the greatest intensity of insolation at approximately noon on this date, and describe the evidence shown on the graph to support your answer. So our answer needs to have a what, everybody? It says to identify the latitude. All right, so our answer is going to be a latitude that has the greatest intensity of insolation. All right. So when you see this word, greatest intensity of insolation, what do you think it means, right? Well, intensity, right, is focusing on how strong something is. Insolation deals with sunlight. So that means that the greatest intensity of insolation is basically meaning which situation am I going to receive the strongest amount of energy from the sun? Right? So greatest intensity incident, strongest amount of energy from the sun. All right. Now here's the rule. All right. You only get the strongest amount of energy based on the altitude of the sun. Now, does the sun have to be very high or very low to get the strongest amount of energy? What do you think? You're correct. It has to be very high. So if I want the strongest amount of energy, it has to be the highest. The sun has to have the highest altitude. It has to have the highest altitude. So when I'm looking at these 4 locations, 90 degrees north latitude, 66.5 degrees north, the equator, and 23.5 degrees north, which one has the highest altitude? Which one does the sun have the highest altitude at noon? Well, the one that has the highest altitude at noon, which is right here, 90 degrees, is definitely going to be 23.5 degrees north. Because if you look, all right, if you take a look and see, right, 23.5 degrees north represents for this line right here. And at noon, it reaches the maximum height. It reaches the maximum height right here. So that's why my answer has to be 23.5 degrees north. So number 4 says, the diagram below. The diagram below shows Earth in its orbit around the sun. Position A, B, C, and D represents Earth at the beginning of each season. Very important. All right, so let's go and do this work. So the question says, identify the season associated with positions A, B, C, and D for an observer in New York State. Okay. So the fact that it's New York State, we're looking for the season. We're looking for the season that's in the northern hemisphere, right? Because is New York above the equator or below the equator? What is it, everybody? Yeah, it's correct. It's above the equator. So let's start with A. And remember, when you're doing these types of problems, the easiest thing to identify is summer and winter. Once you identify either one of these, you can find everything else. All right. So in order to identify summer and winter, we got to look at their North Pole. Let me zoom this in more. Okay. We got to look at where the North Pole is tilted. So when I look at C, position C, the North Pole is tilting towards the sun. So that means that it is what? The beginning of what, everybody? What season? It is the beginning of summer for position C. That is correct. So that means for position A, the North Pole is tilting away from the sun. So which one is position A? The beginning of winter. Now we know that it's going counterclockwise, right? So if winter is here, what season is next? What's after winter, everybody? Position B will be spring. The first day is spring. And then if position C is summer, what season starts at position D, everybody? That's correct. It is fall. Okay. And so, yep, it just says identify. So that's exactly what we did. All right. So once again, when you get a question like this, always try to identify always try to identify at least summer and winter. All right. Summer is always going to be where the North Pole is facing towards the sun. Winter is always going to be facing where the North Pole is facing away from the sun. All right. And then you just follow the arrows to see which season is next. Good stuff. Right. So it says, based your answers of question 5 and 6 on the diagram below. The diagram represents daytime and nighttime on Earth. Point X is a location on Earth's surface. Earth's rotational surface velocity is shown in miles per hour at specific latitudes. So this diagram is focusing on questions 5 and 6. Keep that in mind. So number 5 says, identify the northern hemisphere season that is just beginning when Earth is at the position represented in this diagram. All right, so let's take a close-up to see what is going on. So what is the question asking for? Identify the northern hemisphere season, the season that's happening in the northern hemisphere. So I know that my sun is definitely on the right? Because the sun rays are coming from the, what, everybody? Right. So that means my sun is right here. Beautiful sun. What's going on? What it do? There we go. So now, how can I identify this season? Well, I need to know what the North Pole is doing, right? Is the North Pole tilting towards the sun or away from the sun? It is tilting towards the sun, right? And as a matter of fact, if the North Pole is filled with daylight, that also lets me know what beginning of what season it is about to. So the North Pole is tilting towards the sun, and the North Pole is completely lit up. What season is it going to be, everybody? It is summer. All right. And why is that the case? Because the North Pole is tilting towards where the sun is. the North Pole is tilting towards where the sun is, then that means it is summer in the northern hemisphere. All right, number six. Number six. It says record to the nearest arrow the duration of insolation at location X from one Earth's rotation. Now I know this word, right? These words, duration of insolation. I know that is a mouthful. All that means is the amount of daylight hours. That's all that that means, the amount of daylight hours. So when you ever see, when they're asking for the duration of insolation, all they're asking is the amount of daylight hours. And so when I'm looking at X, I'm looking at this entire latitude. When I'm looking at this latitude, I notice something. Half of this latitude is covered in darkness, right? And half of this latitude is actually light, right? If I see half the latitude gets darkness and half the latitude is lit up, that lets me know one thing. The amount of daylight hours must be split throughout the day as well, too. So therefore, this lets me know if half is lit up and half is dark for this latitude, then that means that there are 12 hours. 12 hours of daylight. 12 hours of daylight. Because half of it is lit up, half of this latitude is lit up, and the other half is in darkness. Okay. Another reason that we know that location X gets 12 hours of daylight is because the latitude that's given at this point is the equator. And one thing we know about the equator, if you're located anywhere on the equator always gets 12 hours of daylight hour. 12 hours daylight. That's what's special about the equator. The equator always gets 12 hours of daylight, no matter what year it is. It always gets what, everybody? That's right, 12 hours of daylight. Let's keep going. All right, number seven. Number seven says, which graph best shows the length of a shadow cast from sunrise to sunset by a flagpole in New York State? So the length of a shadow, that's what we're going to be focusing on. All right. So in our notes, we learned of a very important rule regarding the length of a shadow. What does that determine? What is that based on? If we take a look, it is based solely on the altitude of the sun. And the rule is that the higher the angle, the shorter the shadow. The shorter the angle, the longer the shadow. So as we see here, when the sun is at a very low altitude, your shadow is very long. When the sun is at a very high altitude, your shadow is very, what, everybody? Small. All right. So remember, the higher the angle, the shorter the shadow. The shorter the angle, the longer the shadow. So when I'm looking at number seven, I have to ask myself this question. When it is sunrise, what is the sun's altitude, right? What is the sun's altitude? And so when it's sunrise, the sun's altitude is low, right? When it is noon, the sun's altitude is high. When it is sunset, when the sun is setting, right? The sun's altitude, once again, is low. Now that we know that, now we can choose. When the sun's altitude is low, your shadow is long. When the sun's when the sun's altitude is at noon is high, your shadow is small. And when it's sunset again, your sun's altitude is low, your shadow is long. So which one tells me that at sunrise, my shadow is very long, at noon, my shadow is very small, and at sunset, my shadow is very long again? The correct answer is choice D, right? The length of the shadow is very high at sunrise and sunset because the sun's altitude is low. Okay, number 8 says, base the answer to the following question on the data table below. A student records the hours of daylight and the altitude of the sun at noon on the 21st day of every month for 1 year in Buffalo, New York. So they're recording the amount of hours of daylight and the altitude of the sun at noon for each day of the month. Each 1 day out of the month for the year. On the graph below, draw a line to represent the general relationship question. It's a relationship question, people, between the altitude of the sun at noon and the number of hours of daylight throughout the year at Buffalo. Okay? So I need to know what is the pattern. So when there's a relationship question, we need to know the pattern. There's a pattern between what? Between the hours of daylight, right? The hours of daylight and the altitude of the sun at noon, right here. What is the relationship between these two? So let's take a look. One thing I noticed, right? As the numbers are getting bigger, right around here, as the numbers are getting bigger, what's happening to the altitude of the sun at noon? It looks like it's also getting bigger, right? So far, I see that when the hours are getting bigger, so are the numbers, they're getting bigger. Okay? Then, when the numbers start getting smaller in this area right here, what is the altitude of the sun doing? Well, it looks like the numbers are getting smaller as well, too. Well, from 63 to 55, 47, 39. So when the numbers are getting smaller on this side, over the hours of daylight, the altitude of the sun is also getting smaller. What's the pattern? Well, when one side is getting big, the other side is getting big. When one side is small, the other side is getting small. What is the name of this relationship, everybody? It is what? A direct relationship. When one category is increasing, the other category is increasing as well. And what do we learn about how do we draw direct relationships on a graph? Do we remember? It is, let me just get this out the way. Let me erase this stuff. Get this out the way. All right. So in a direct relationship, it's just a diagonal line. Because a direct relationship means when one category increases, the other category increases. When one category decreases, the other category decreases. Is directly affecting the other, a direct relationship. All right, number 9. Number 9 says basic answers to the following question on the roadmap below. Letters A to B represents locations on Earth's surface. And X says at which letter location on December 21st is the sun directly overhead at so and noon? All right, so this is straight from my notes. There's only one latitude. There's only one latitude on December 21st where the sun is directly overhead. And let's see what it says. On December 21st, sorry. On December 21st, the latitude where the sun is directly overhead is 23.5 degrees south. So that's something we got to keep in mind. So I'm just going to write here at December 21st, the latitude is 23.5 degrees south. Y says, at which letter location is March on March 22nd is the sun directly overhead at solar noon? Now remember from our notes, which we have to memorize, on March 22nd, right? So anywhere between March 21st and March 23rd, the sun is directly over your head, 90-degree angle at the equator. So that means we're going to write that down too. So on March 22nd, the latitude where the sun is directly overhead is 0 degrees, the equator. Now let's look at Z. At which letter location on June 21st is the sun directly overhead at solar noon? When we look, as we said right here, on June 22nd or June 21st, the sun forms a 90-degree angle at noon at 23.5 degrees north. So therefore, for June 21st, the latitude is 23.5 degrees north. Okay? So if I start with December, which letter is the sun directly overhead? It has to be at 23.5 degrees south. When I zoom in, 23.5 degrees south looks to be right south latitude right here. So 23.5 degrees south will be somewhere around here. And what letter is that close to? About to draw a line. I know it's not the same. So that lets me know automatically the letter B. December 20 is for letter B. Now for March, which letter is at 0 degree latitude? For March, the one that's at 0 degree latitude is letter C. And for June 21st, which letter is at 23.5 degrees north? For June, or 23.5 degrees north is right here. And the letter closest to it is letter A. And so that is your correct answer. All right, December 21st. So, sorry. So December 21st is going to be, oops, change color. December 21st is going to be letter B. March 21st is going to be letter C. And June 21st is going to be at letter A. Those are your answers. All right, number 10, it says basic answers to questions 10 through 13 on the table below and on your knowledge of earth science. The table provides information about sunlight received on 4 dates of a certain year. Letter A represented a date. The arrows indicate the sun's direct rays. Okay. So 10, it says identify one possible date represented by letter A. All right, so what is some information we know about letter A? Letter A is the spring equinox. That already automatically right then and there. It lets me know. It lets me know. All right. Equal day and night Sun is the horizon at poles, direct ray at the equator. Every latitude is given the same amount of daylight hours, right? So we know it's an equinox date. Which equinox? Spring equinox. When is the spring equinox, according to your notes? March 21st. It's correct answer for choice A, for number 10. State the number 11. Number 11 says, state the number of daylight hours occurring north of the Arctic Circle on June 21st. All right. Well, first things first, what is the latitude of the Arctic Circle according to our notes? When you look back at your notes, it is right here. When you look back at your notes, the Arctic Circle has a latitude of 66.5 degrees. Okay, so the Arctic Circle, and I'm going to zoom in for June 21st. The Arctic Circle is basically that latitude right below the North Pole. So the Arctic Circle is right here. Arctic Circle is right here. Now, what's great about the Arctic Circle is that when I'm looking, I notice that this latitude right here is completely filled with daylight, right? This latitude for this diagram is all daylight. So if this latitude is all daylight, there's no darkness on that latitude at all, then that means that it receives 24 hours of daylight. That's the correct answer. All right, number 12 says, explain why the sun's direct rays are at different latitudes as Earth revolves around the sun's. What they're saying is that if you pay attention, right, because the reading says right here, in number 12, the reading says the arrows indicate the sun's direct rays. Sun's direct rays basically describing that the sun is at a 90-degree angle from the ground. So basically, this is the ground, right? The sun is directly overhead, giving direct 90-degree rays. So they're saying that this happens at different locations throughout the year, right? So at one point, September 23rd, pointing at the equator. At December 24th is pointing at 23.5 degrees south. At date A, at the equator again. And at June 21st, it's pointed to 23.5 degrees north. So the question is asking pretty much, why is it that throughout the year, that different latitudes are getting direct rays? And the answer is simple. It's simply because the Earth's axis is tilted. That's why the Earth's axis is tilted. These are the following answers that you could have stated. If you look at number 12, any of these options would have been fine. If you want to pause the video, you can do that. So that way you can just check if one of your answers is similar to any of these here. But basically, it's focusing on the fact that the Earth's axis is tilted. Number 13 says, state the numerical latitude. So once again, your answer is a latitude at which the sun is directly overhead. We've seen this time and time again, right? Directly overhead means what again, everybody? Directly overhead means that the sun is at a 90-degree angle from the ground at noon on December 21st. Include the units and compass directions in your answer. Which latitude is the sun directly overhead at noon on December 21st? If you look at our notes, which this we have to memorize, You have to memorize. This is a topic where we have to study, people. The reference evidence is not going to help us. All right, December 21st, it says it right here. What latitude the sun forms a 90-degree angle? 23.5 degrees south. Right? And so that is our answer. Our answer is 23.5 degrees south. And yes, that's an S. But no, it looks like a number 5, but it's 23.5 degrees south. All right. We got this. Number 14, the table shows the duration of insolation at different latitudes for 3 different days during the year. Okay. So 3 different days during the year, they're giving us the duration of insolation. What does the duration of insolation mean? Once again, everybody? What? Yes, amount of daylight hours. Amount of daylight hours. We got this, people. Come on. All right. So it says which dates are represented most correctly by day 1, day 2, day 3, respectively. All right. So one key thing that I notice about all of these, is there a pattern you notice about all these latitudes? All these latitudes are focusing on the north side, right? You know what that tells me? That tells me that they're just giving us the amount of daylight hours for whatever's happening in the north, right? In the northern hemisphere. What's another pattern that I notice? Well, day two is all 12 hours. If it's all 12 hours, that lets me know that day 2 is definitely has to be only one day. Day 2 has to be an equinox day. It has to be an equinox day. So it's either somewhere September 21st or March 21st, right? Or one of the ranges that we discussed earlier, right? 21st to the 23rd, something like that. So that's the first thing. The second thing I notice is that day 1, the northern hemisphere has a lot more hours in day 1 than it does in day 3. You see how in day 3, the amount of daylight hours is very small? Well, think about us when we're in New York. What season do we have the lowest amount of daylight hours? What season, everybody? Winter. So the fact that day 3 is giving me the smallest amount of daylight hours, right? It's less than 12 for all of them except the equator. That lets me know it's the winter solstice, December 21st. And day 1, the fact that I am getting 24 hours, right? 24 hours, large amount of daylight hours on day 1 than compared to day 3, right? Day 1 compared to day 3, large amount of daylight hours. That lets me know day 1 has to be what, everybody? Let me hear you say it. Day 1 has to be the summer solstice. And which option shows what I've just written down? Where day 1 is the summer solstice, day 2 is the equinox, and day 3 is the winter solstice. Choice 2. Boom. We got this. Good stuff. All right. And number 15. Number 15 says, let's get a close up. Number 15 says, in which diagram is the observer experiencing the greatest intensity of insolation? We just did a problem like this before. Greatest intensity of insolation means when the sun gives us the most amount of energy. When does the sun gives us the most amount of energy? When the sun is at the highest altitude. When the sun is at the highest altitude, that's when we get the greatest intensity of insolation. So, which one of these choices is the sun at the highest altitude? Yep, when you look at all four, which one has the highest angle? And the one that has the highest angle is choice D. All right? This makes sense? Good stuff. All right. So, therefore, that's all the questions. Definitely be blessed. And until next time, take care, guys.